Hello guys, this is Engineer Marcelo T. Abera Jr. and welcome sa isa na namang tutorial dito sa aking YouTube channel. So ngayon guys, sa video na ito, ang pag-uusapan natin ay tungkol sa pag-design ng doubly reinforced beams. Okay, so i-define muna natin guys kung ano ba talaga yung doubly reinforced beams. Okay, so doubly reinforced beams guys are beams with both tensile and compressive steel reinforcements. So katulad nitong nandito sa figure guys, meron tayong tension steel reinforcement and meron tayong compression steel reinforcement. So ibig sabihin guys, both the tension and the compression side ay merong steel reinforcements. So, ang tawag natin dyan is doubly reinforced beam. Kapag ka nasa tension side lamang guys yung ating steel bars, then it is called singly reinforced beams. So, why design a doubly reinforced beam? So, take note guys na kailangang i-design natin ang isang beam as doubly kapag ka, for example, na-compute na natin yung maximum nominal moment na kayang i-resist ng singly reinforced beam, pero mas maliit pa din yung maximum nominal moment na yun sa actual nominal moment na i-resist ng beam in the future. So in that case guys, kailangan na natin i-design yung beam as doubly reinforced beam. So para mas maintindihan natin guys, if a beam cross-section is limited because of architectural or other considerations, it may happen that the concrete cannot develop the compression force required to resist the given bending moment. So, to increase the moment capacity ng beam, so para ma-increase natin yung moment capacity ng ating beam, another resisting couple is added to the beam by adding steel in both the tension and compression sides of the beam. For example guys, we have a beam na kung saan fixed na yung kanyang cross-section, hindi na natin pwedeng i-increase yung kanyang width at saka yung kanyang total depth. Ang gagawin muna natin guys is itatry muna natin siyang i-compute kung pwede ba siyang maging singly. So, di ba nga kapag nag-singly tayo guys, dalawa lamang yung forces dito. Yung tension force dito sa may steel bar na to, dito sa may tension side, and of course, yung compression force dito sa ating compression side. So, of course, yung ating tension force will be T is equals to AS. Sabihin natin guys na T1 equals to AS1 multiplied by F sub. Tapos yung ating compression force is compression concrete force, that is C sub C equals to 0.85 F sub C prime multiplied by A times B. So, obviously, yung ating compression concrete force will act at the centroid ng ating compression concrete area. So, this will locate here at this point at A over 2 from the extreme compression fiber. So, ibig sabihin, itong kanilang distance will be D minus A over 2. So, di ba nga guys, i-compute natin guys yung kanilang nominal moment. So, yung nominal moment is the moment created by these two couple forces. So, that is equals to T1 multiplied by D minus A over 2. O di kaya, pwede natin siya i-compute as compression concrete force multiplied by D minus A over 2. So, ngayon guys, so kapag for example, yung na-compute natin na nominal moment is kulang, kung for example, yung ating na-compute na Mn1 is mas maliit siya sa ating Mn, actual nominal moment na i-resist ng ating beam, so syempre, hindi pwedeng i-design lang natin siya ng ganyan kasi kapag i-design lang natin siya ng singly reinforced beam, ang mangyayari is mag-fail din yung ating beam. So of course, ang gagawin natin para mag-increase yung kanyang nominal moment capacity is magdadagdag tayo guys ng compression bars and magdadagdag din tayo ng tension bars. Okay. So kapag nangyari yan, ibig sabihin nagdagdag din tayo ng force, resisting force sa may tension side and resisting force sa may compression side. Okay, so ito na guys yung nadagdag, that is T sub 2 is equals to AS2 multiplied by Fy. Yung AS2 dito is yung nadagdag lang na area ng ating bars guys, yung violet na nandyan. Tapos, yung ating compression steel force is equals to AS prime multiplied by Fs prime. Take note that the distance between these two forces is D minus D prime because C sub S is located at a distance D prime from the extreme compression fiber. So kapag kinompute natin guys yung kanilang nominal moment, it will be T2 multiplied by D minus D prime, or pwede natin siyang i-compute as C sub S multiplied by D minus D prime. So kapag ngayon kinompute natin yung kanyang nominal moment capacity, then it will be Mn1 plus Mn2. So ito na yung total nominal moment capacity ng ating beam. So na-increase guys yung ating nominal moment capacity by adding bars sa may tension side at saka sa may compression side. So ayun, so I hope naintindihan natin guys yung idea kung bakit natin i-design yung isang beam as doubly reinforced rectangular beam. So Another information lang guys, take note that compression steel reinforcement is not normally required in sections designed by USD or ultimate strength design or strength design method which account for the full strength potential of the concrete on the compressive side of the neutral axis. So usually guys, no, na-decrease na nga yung possibility na ma-design natin yung isang beam as doubly, no, dahil nga no, sa USD or sa ultimate strength design, ginagamit natin yung full strength potential ng concrete, no. So kaya ang nangyayari, mas malaking force yung kaya niyang maibigay, so mas maliit yung possibility na ma-design nga natin yung isang beam as doubly reinforced beam. Pero yun na nga guys, no, na nangyayari pa din guys yung doubly reinforced beam. So at yun na nga yung ating gagawin sa video na ito. Na magdi-design tayo ng beams as doubly reinforced beams. It has been found that the inclusion of some compression steel will reduce the long-term deflections of members. So, gagawa tayo guys ng another video for long-term deflections. Ito yung mga deflections na nagsistay sa beam mula nung in-install siya or kinonstruct siya hanggang sa tumagal nga yung beam. So, ito yung mga deflections na nagsistay. Sana all nagsistay, di ba? Okay, so yun. So, third na information guys is that continuous compression bars are also helpful for positioning stirrups by tying them to the compression bars and keeping them in place during concrete placement and vibration. Katulad nitong nandito sa figure natin guys, no, dahil sa compression bars, merong nakakapitan nga yung ating stirrups. Okay, so take note lamang guys, no, na kahit na i-design natin yung ating beam as singly reinforced beam. For example guys, no, itong ating beam is na-design lang natin siya na meron tayong kailangan na tatlong bars ito sa tension side. So take note na kapag kinonstruct na natin guys yung ating beam, kailangan natin maglagay pa din ng dalawang bars dito sa may ibabaw. Ang tawag natin dyan is hangers, no? Dahil kailangan yan para makakapitan nga ng ating stirrups. So ayun, so clarification lang guys sa mga students kasi usually nagtataka yung mga students, so ibig sabihin pala kapag ka naglagay tayo ng dalawang hangers, magiging doubly reinforced beam na siya and may increase yung kanyang nominal capacity, moment capacity. Actually guys, no, hindi, no, kasi kapag ka naglagay tayo, nagdagdag tayo guys ng compression bars sa may compression side, dapat magdagdag din tayo sa may tension side para mag-i-increase yung kanyang nominal moment capacity kasi parang nagdagdag tayo ng additional couple sa beam na yun, no? So, ibig sabihin guys, no, kapag ka-compression bars lamang yung dinagdag natin, hindi tayo nagdagdag ng tension bars, no, walang madadagdag na nominal moment kasi isang force lang yung magdadagdag sa ating beam doon lang sa may compression side, so wala siyang additional na moment. So, ibig sabihin nun guys, no, ang mangyayari is, mag-i-increase yung kanyang strength, compression strength lang sa maibabaw yung kanyang mag-i-increase. Pero sa may tension strength, hindi siya mag-i-increase. So, wala ding mangyayari, parang hindi rin nag-increase yung kanyang strength. Kasi yung nominal strength, yung ating basehan dito sa may beam, no? So, yung capacity niya against moment, against bending. Okay, so tests of doubly reinforced concrete beams have shown that even if the concrete compression crashes, the beam may very well not collapse if the compression steel is enclosed by stirrups. So yun, so proven and tested na daw na kapag meron tayong doubly reinforced beam, no, kahit mag-crash nga yung ating compression concrete, no, ay maaaring hindi pa rin mag-collapse nga yung ating beam, no, dahil nga nandun pa din yung ating compression steel. Okay, so dito na tayo guys, no, sa pag-design nga ng doubly reinforced beam. So usually, ang hinahanap natin guys, kapag nag-design tayo ng isang doubly reinforced beam, ang hinahanap natin is yung number of compression and tension bars. So kailangan na, ang final natin na computation dito is makuha natin kung ilan yung ating kakailanganing compression bars and kung ilan yung ating kakailanganing tension bars. So ano-ano nga ba guys yung mga steps para makapag-design tayo ng beams, no, na doubly reinforced? Okay, so una is kailangan muna natin i-compute yung required nominal moment. That is yung MN. So yung MN guys is ito na yung moment na i-resist ng ating beam in the future. So para makompute natin si MN, that is gagamitin natin yung MU must be equal to phi MN. So MN yung ating gagamitin, of course, yung ating phi dito is set natin siya to 0.9 para maging tension controlled yung ating beam. Okay, so pangalawa, we have to find out whether the design will be singly or doubly reinforced beam. So, kailangan malaman natin kung i-design natin yung beam as singly or doubly reinforced beam. So, take note guys na hindi choice ng designer kung gusto niyang gawing doubly or gusto niyang gawing singly. So wala siyang choice, no? Kung mangyayari yan, depende sa computation. So kung lumabas sa computation, kailangan siyang singly, is-singly talaga dapat siya. Pero kung lumabas sa computation, kailangan siyang doubly, then dapat siya i-design as doubly reinforced beam. Okay, so dito sa number 2, kailangan natin i-compute muna yung maximum nominal moment kung yung beam is i-design siya as singly reinforced beam. So, bali no, tatawagin natin siyang MN1, okay? So, bali no, para makuha natin yung MN1 na yan, guys, no, isa-set natin yung rho 1 equals to rho max. And we will solve for the AS1. So, yung AS1 na yan will be equal to AS max kasi nga, diba, sinet natin yung rho 1 as rho max. So, ito yung maximum area ng steel reinforcement kung singly. Kasi guys, kapag maximize natin yung area ng steel, now, for singly reinforced beam, hindi makukuha natin yung maximum magnitude ng ating tension force and makukuha natin yung maximum nominal moment kung singly reinforced beam nga siya. Okay? So ngayon na guys, no, pwede natin i-compute na ngayon yung maximum nominal moment no, kung singly reinforced beam siya, and that will be called MN1. So we will compute MN1. That is, again, the maximum nominal moment if the beam will be designed as singly. And i-compare natin yan to MN. So, take note, kung yung ating MN1 na yun, guys, is mas malaki or equal to the nominal moment, then ibig sabihin, kakayanin ng singly reinforced beam na i-resist yung nominal moment na required natin dun sa number 1, no? Kasi nga, no, yung MN1 na yan is the maximum moment na kayang i-offer ng beam kung singly reinforced beam siya. So, hindi na natin kailangan ng additional na moment kung kakayanin naman niya yung nominal moment na na-compute natin sa number 1. Pero, kung yung ating MN1 na na-compute, guys, is mas maliit sa MN1 na na-compute natin sa number 1, then the beam must be designed as doubly. Kasi ibig sabihin nun, guys, na kahit i-design natin siya singly, yung maximum nominal moment niya is hindi pa rin kakayanin yung nominal moment na mag-a-act sa beam natin, no, in the future. So, kailangan natin siyang dagdagan ng additional nominal moment, no, and that will be a doubly reinforced beam. So, ayun na nga guys, no, since ang ating topic dito sa video na ito is design of doubly reinforced beams, then i-discuss natin guys kung paano i-design nga yung doubly. So, dapat guys, yung MN1 niya must be less than sa MN. Okay? Okay, so again guys, now ganito yung mangyayari. So, ibig sabihin guys, kung yung MN1 natin is less than sa MN, okay, then kailangan nating magdagdag ng additional nominal moment. Ito na yung MN2. So, kailangan nating i-compute ngayon yung lacking na nominal moment sa ating beam. So, madali lang naman siya. Itong equation na to, MN natin is equals to MN1 plus MN2. Hindi makukuha natin guys si MN2. Okay? Okay, then next is, we have to check whether yung compression steel will yield or not. So, paano natin siya magagawa? I-compute natin guys yung ating compression steel strain and then i-compare natin siya sa ating yield strain. Ngayon, kung yung ating compression steel strain is greater than or equal sa ating yield strain, then that means the compression steel will yield. So, ang gagamitin natin dito guys na Fs prime will be equal to F sub y. Pero kung yung ating compression steel strain is less than sa ating yield strain, then yung ating compression steel will not yield, and ibig sabihin nun, yung ating F sub S prime will not be equal to F sub y. In fact, yung ating F sub S prime must be less than sa ating F sub y. So ngayon, anong gagawin natin guys kapag nag-yield yung ating compression steel, and ano yung gagawin natin kapag hindi siya nag-yield? Okay, so kapag nag-yield yung ating steel, no, we will proceed to the next step. No, kapag hindi nag-yield yung ating steel, ito yung gagawin. We have to compute the Fs prime, and that is gamit itong compression steel strain is equals to F sub S prime divided by the modulus of elasticity ng ating steel. Okay. So, ngayon guys, no, after dito, proceed na din siya sa step 5. So, yun. So, proceed sa step 5. That is to compute the required compression steel area, or that is AS prime. So, we have to choose the bar diameter here and compute the number of bars. So, madali na lang naman yan guys, no? Kasi alam na natin kung paano gawin yan mula pa nung design of singly reinforced beams. Okay, then para sa number 6, last na to, i-compute natin yung required tension area, or that is tension steel area AS. So all we have to do for that is add natin si AS1 at saka si AS2, and then we have to choose the bar diameter and compute the number of bars. Okay? Okay, so take note guys, no, na kapag natapos na tayo mag-design ng doubly reinforced beam, kailangan natin siya agad i-analyze, no? So bakit natin siya i-analyze? That is to find out kung magiging safe ba or kung safe ba yung ating design or hindi. So paano natin malalaman guys kung safe yung ating design or hindi? That is, magiging safe siya kung yung ating M sub U is less than or equal to phi mn. So kapag hindi ito na-satisfy guys, then that means hindi siya safe. So kailangan natin ulitin yung ating design ng doubly reinforced beam. So ayun. Okay, so same lang guys no yung ating analysis of doubly reinforced beams guys. No, meron akong video, separate na video about that. No, diniscuss ko doon sa video na yun kung paano mag-analyze ng doubly reinforced beams. So I hope na panoorin nyo yun no kasi hindi ko to i-explain ng bonggang-bongga dito sa video na to kasi yung topic natin dito guys is design of doubly reinforced beams. So ayun guys no. So yung ating magiging first step sa analysis is i-compute yung factored moment na MU, which is na-compute natin to sa design pa lang, di ba? Tapos again, i-compute natin yung ating A at saka C no using the equilibrium equations assuming F sub S prime is equals to F sub Y. So yung ating equilibrium equation na gagamitin dito is yung T equals to C sub C plus C sub S, okay? And then we will compute the strain in compression steel to verify the assumption that it is yielding. So para malaman na yielding siya, then dapat yung ating compression steel is greater than or equal sa ating yield steel. And kapag hindi siya yielding, then that means yung ating compression steel is less than sa ating yield strain. Okay? So, ayun guys, no, kapag yung ating compression steel is yielding, so ang gagawin natin is i-compute natin yung ating tension strain and then determine the value of phi. Then after natin ma-compute yung phi guys, then we can now compute for phi mn, and then bale no, madali lang naman yung pagkuha ng mn kasi we know that mn here is mn1 plus mn2, that is t1 multiplied by d minus a over 2 plus t2 multiplied by d minus d prime. Okay, ngayon no guys, after natin ma-compute yung phi mn, pwede na natin siya ma-compare sa ating na-compute na m sub u kanina. Again guys, kapag na-satisfy yung ating equation na to, no, kapag yung mu natin is less than or equal sa phi mn, then that means it is safe. Otherwise, kailangan nating ulitin yung design. Okay, so ngayon guys, no, what if hindi naman mag-yield yung ating compression steel? So actually, diniscuss na nga din ito guys sa ating analysis na video, no? Panoorin nyo na lang yun. So we have to ulitin natin guys yung equilibrium equation, this time assuming that f sub s prime is not equal to f sub y. Okay, then we will solve for A and C here, and then after that, we have to compute the compression steel strain, and then we have to find out na hindi talaga siya dapat mag-yield. Kailangan lang natin i-confirm guys, that the compression steel strain is less than sa ating yield strain, no? Dapat ito talaga yung mangyari guys, no? Kasi na-find out natin dito pa lang sa taas na yung compression steel natin will not be yielding. Okay, then we have to compute Fs prime, which must be less than F sub y kasi hindi nga siya mag-yield. Okay, then after that, we can now compute the tension strain. Then we have to determine the phi. So, bale, dito na yung ating step, no? Parang katulad na rin nito. Okay, then we have to compute the phi mn, and then after that, ay i-compare natin siya to M sub U, and kapag na-satisfy natin to, then it is safe. Then otherwise, we have to repeat the design. So, redesign kapag hindi na-satisfy ito. Okay, so that's it guys, no? Okay, so reminder lang guys, na sa pagdidesign ng doubly reinforced beam, no, maaaring gumamit tayo dito ng mga formula na ginamit natin before sa singly reinforced beam. So, una is, di ba nga guys, naalala nyo yung pag-compute ng maximum rho, that is, yung maximum rho is when the tension strain is equals to 0.005. So, eto guys yung shortcut na formula nun. Okay, this is the derived formula para sa pag-compute ng rho. No? Take note that this rho is computed kung yung ating tension strain is equal to 0.005. So, take note, nakadepende lang siya sa value ng F sub C prime, F sub Y, at saka beta 1. Okay, so dito guys, no, kailangan din natin gamitin guys yung ating formula na M sub U equals to phi BD squared rho Fy multiplied by 1 minus rho Fy over 1.7 F sub C prime. So, gagamitin natin siya guys, no? And then, take note na maaaring gamitin din natin yung ating formula na A is equals to ASFY divided by 0.85 F sub C prime times B. Alam na natin to no, kasi itong formula na to is galing lamang to sa formula na compression force is equals to tension force. Kailangan din natin dito guys yung ilang mga provisions sa NSCP at saka sa ACI, katulad na lamang ng pag-compute ng beta 1. Okay, so based sa NSCP 2015, ito yung ating provision. And para sa ACI 31814, ito yung ating provisions. Okay. And then take note guys, yung beta 1 na yan, ginagamit natin sa pag-compute ng C, which is equals nga to A over beta 1. Okay, tapos para sa pag-compute ng phi, kailangan natin guys itong table na to from NSCP at saka sa ACI, no? So dito bali, no, kailangan natin i-classify muna yung ating beam, kung compression controlled siya, transition or tension controlled, and then we can get the value of phi based dito sa may part ng table na nandito. Okay, dito. Hindi dito guys, no, kasi dito is for transverse reinforcements na spiral. Okay, so dito tayo sa may other. Okay, sa susunod na video ay i-discuss natin itong example problem na ito. Okay, so this is an SI problem guys, no? So bale, ayun, so see you sa next video guys. Bye-bye!